So to give you a glimpse into what tomorrow may look like, I'd like to invite Jim Lynch to the stage.
I'm good, thank you. All right, thank you, Sarah. Good morning. So at the beginning of this session, Nicola talked about what is possible with data and automation. And Sarah, of course, just laid out how, with BIM 360, we're building a foundation to help you realize that potential. So let me start out by describing where we're headed with BIM 360, specifically as it relates to collaboration. Now, I'll start by talking about a topic we raised last year here at AU, Project Quantum. Quantum is an initiative for connecting applications and services via a common data platform for efficient project delivery across all AEC disciplines. The goal of Quantum is to streamline data flow from design to fabrication all the way through to the construction site. Now, in order to fully understand what that means, let's put it in the context of where we are today. As Sarah shared with you, today there are many ways to collaborate with your teams. In BIM 360, we first introduced file-based collaboration offered by document and data management services for storage, for sharing, and for reviewing. Now soon, we're introducing technology for cloud work sharing, where teams have access to shared central models using BIM 360 to coordinate milestones and deliverables across BIM project teams. Tomorrow, the technology born as Project Quantum will be integrated into BIM 360 and will enable an entirely new level of collaboration and data exchange between design, fabrication, and construction across any platform. This will enable tighter collaboration and control over project workflows, and it's essential to support what comes next. So let me set some context. In the next 20 years or so, there will be 2 billion more people on the planet. Now, just think of the demand for buildings and infrastructure that will be required to support this population, most of whom will live in cities. With the lack of predictability and historical low productivity, we must ask ourselves, are the same old methods the best approach to meet the demand? Now, using an example from my hometown of Boston, of course you can't tell with my French accent, the Big Dig, a mega infrastructure project, was meant to take 6 years to complete. Instead, it took over 20 years to complete, with the cost overrun of 190%. Now, I know that's an extreme example, but we all know projects that completely miss their schedule and/or their budget. The point is, we cannot meet the demand if we don't consider new ways of designing, fabricating, or constructing. Progressive thinking, innovation, and determination are critical to addressing the industry challenges we all encounter. Specifically, we must look to the manufacturing industry in sectors such as automotive and consumer products, which must really produce large amounts of high-quality products consistently and efficiently. We believe the AEC has to learn lessons from the manufacturing world in order to boost productivity. The industrialization of construction is the convergence of manufacturing and construction processes. In the next few years, this convergence will radically change the way we design buildings, make their components, assemble them on site, and manage the processes and data. In the future, buildings will be assembled from components and modules that were manufactured off-site. This transformation will require all project stakeholders, designers, engineers, fabricators, and contractors to adopt new methodologies. This means designers will have a greater impact on how buildings are made and constructed. This idea is known as Design for Manufacture and Assembly, or DFMA. DFMA focuses on manufacturing throughput and efficiency of assembly and is a well-established approach in markets such as automotive. For sure, AEC is an extreme case of mass customization. However, if we really look at it, the majority of the buildings we make have repetitive content. I mean, just think of any residential building, hospital, hotel, school, or data center. And today, we simply don't have a smart way of dealing with them, neither in the design process nor in the construction process. To meet the demand without sacrificing quality or increasing our environmental footprint, we must find a way to help building design process consider more modular and standardized approaches. Our tools will support design for manufacturing and assembly by first codifying intelligence and logic to help design buildings that are optimized for off-site construction, and by embedding fabrication knowledge to enable factories to streamline their processes. So imagine, for example, if you had a DFMA assistant for facade panelization that could bridge design, estimation, procurement, and fabrication. An assistant that helps fabricators create smart libraries that will contain all manufacturing knowledge and constraints, streamline the estimation and engineering of the facade, and empower designers to connect design and fabrication. Or a DFMA assistant for modular construction. This hospital that you see here was designed by the Nordic Office of Architecture, and it includes a high level of repetition in terms of the floors, the rooms, and the components. And by the way, I really want to thank Nordic Office of Architecture for sharing this project with us. But imagine if a smart assistant could help the architect focus the design on the way buildings are built and delivered. A sort of analytical tool that, based on input and previous experiences, helps designers create a library of standard but configurable modules. The process would start with conceptual parametric placeholders that are simple in geometry but extremely, extremely rich in data. This would initially help play out different design scenarios, but it would also enable early estimation and procurement. In later stages, the modules and components can be further developed, getting more precise and detailed in terms of geometry and also supply chain data. Now, of course, this approach doesn't mean that all modules must be the same. On the contrary, modules can be mirrored, configured, and adjusted. DFMA will allow for mass customization while at the same time streamlining processes from design to manufacturing and assembly. Individual modules can be designed for flat pack delivery, similar to how one of our newest partners, Project Frog, is working, or volumetric modules, as we see here, again, from Nordic Office of Architecture. The individual modules can be combined further into bigger cross-discipline assemblies that hold fabrication intelligence and assembly instructions. But what will the AEC factory of the future look like? The make part of the process is also changing, and the off-site construction factories of the future will be producing multi-material, multi-discipline panels and modules all in the same place. The machining process will become automated, following recipes and fabrication logic delivered directly from the DFMA-empowered BIM data. And assembly instructions will be generated from these smart models. The sequencing for producing components will be managed to optimize factory efficiency while also meeting the project needs. Compared with working on-site, off-site construction is safer and more efficient. It's also easier to manage quality and to ensure precision. Components created in these factories will have individual identifiers, such as QR codes, that allow for tracking and monitoring from design to production, through delivery, through installation. This would be done via a collaborative cloud solution, similar to how one of our partners, Manufacton, does it. Manufacton provides a SaaS platform for construction firms to plan, track, and manage prefab elements across all supply chain members. including detailers, procurement, shop foremen, and field superintendents. So finally, we move to the construction site. Construction sites of the future will become increasingly automated. Imagine an assembly line on the construction site instead of in the factory. Assembling, rather than constructing building parts on the project site, will drive greater efficiency. And there'll be less waste and therefore less impact on the environment. Installation instructions coming from the BIM model will enable flawless assembly of building parts on the job site. And as I mentioned earlier, QR codes embedded in the modules at the factory will allow for live tracking from production, delivery, and ultimately installation. And of course, this will enable just-in-time delivery and just-in-time production. For the first time, data flows from the design to the project site seamlessly. Now, we're also seeing inspiring innovation in robotics on the construction site. Recently, I had the opportunity to visit a DFAB house at ETH Zurich, where robots were building up rebar and laying complex brick walls. This is part of the Swiss National Center of Competence in Research. We're also seeing large-scale building structures, or even entire buildings, being 3D printed using various materials, such as concrete, clay, and even polymers. Just like you see here from the team at X-Tree. Or how about self-driving heavy equipment that makes construction safer, faster, and more affordable, such as built robotics? And we're conducting research on concepts for VR-controlled construction robots that have the machine learning capabilities that learn how to do installations over time. The convergence of manufacturing and AEC is the future of construction. Progressive thinking, innovation, and determination are critical to meeting the demands and embracing the opportunities in front of all of us. This transformational approach to the way buildings are designed, procured, and delivered will radically change our lives and will enable us to meet the demands of the future. Think of how robotics and automation have changed automotive production and the resulting improvements in the cars we drive today. Think about the automotive manufacturers that embrace new technology and are reaping success. And think about those that haven't. Are you ready to embrace DFMA? Are you ready to consider factory automation and on-site assembly over traditional construction methods? Now, before I leave, I'd like to recap what you heard this morning. To paraphrase both Nicola and Sarah, our job is to provide you the tools you need to connect people, processes, and data. That's possible today with BIM 360. Today, you also heard us announce a unified BIM 360 platform and how we're extending BIM 360 to include design collaboration workflows across AEC. You also heard we're making new investments to connect workflows and increase the value of data. We're giving you more access to the software integrations you've been asking for. And finally, the convergence of manufacturing and AEC is real, and it's happening now. Autodesk was your partner at the very beginning of the BIM transformation, and we're committed to partner with you in the future of design, fabrication, construction, and collaboration. Your potential is limitless. I'm deeply excited about what we can do today and in the future, and I hope you are too. Let's go build the future together. Thank you.